Okay, so I'm making this video because I think I've got it down to like the core aspects of how intelligence functions and how we can like probably put intelligence into machines. Now the thing is that um, the brain is a network. So that means that there's connections and they intertwine with each other, and so it's like Facebook. You know, you have if you graph, like they used to graph the internet, but then it got too big. But so now they graph Facebook and they show all these like subgroups of like these are the people that like cakes, and these are people that like pizza, and so under hundreds of categories they group people by and those connections between them and like their friends and how their friends like there's at least like three orders of distance or whatever that connect like me to Obama on Facebook, or like you to Obama on Facebook. There's like three hops of friends that gets you to there. So the thing is, the brain is a network, and the network changes based off of the signals it gets from the outside and from the inside. So, for example, if you write a book, if you write a novel, like if you write Harry Potter, first of all, you have to know all the stuff about the world, and that has to um, so the network has to like curl into itself, or like just like have all this interconnection. So the network has to be interconnected, and so like when she was writing her story, she was thinking about like Tolkien, or I don't know who wrote Harry Potter, but like her brain was a network, and it connected all these things together. Now the thing is that since the brain, um, the way it's connected in a hierarchy, but it's connected in a multi-dimensional hierarchy. So that means that it's called sparse coding. So the thing is that there's like little fragments that represent a memory, and then if you trigger all those fragments at once, they trigger the groups of that are all stored within the same space. So if they're all stored in the same space, it's called sparse distribution coding. And so the thing is that like we need that because we are three-dimensional creatures. Like if we were hunter-gatherers, then the males would go out and hunt rabbits, and the females would go out and like pick berries or whatever they did. And so the thing is that um, we need real-time signals going from like the brain to the hand to throw the spear to get the rabbit to survive and not die. And so the thing is that like so the network has to create a model of the outside world. And so the thing is that when it creates this model, it yeah, it's well it's the network has to model reality. And so like I heard that like hunter-gatherers had a photographic memory. So that means that they went on a trip 10 miles into like unknown territory, and they remembered everything about their experience of that past 10 miles. And like humans don't really do that now, but what the brain has, that it's called nested loops. So the thing is that like this part could be connected to this part, and then it's connected to other parts, and so the thing is that like it's creating loops. Like I said that the sparse distribution is actually just trying to activate the loops inside the brain. So because it's trying to activate the loops inside the brain, um, it has to change the brain. So like I think I said this before, but like the network, you have a network in your brain, and it has to change. And it has to change so it can better represent the outside world to you. So the thing is that biology found out a way to do it with sparse distribution, and by also like connecting like real time, like the hand movements to like something up here, and the connectome, or the white matter tracks that connect the 180 regions of the brain. That's important too, because there's this thing like reasoning, like language is important, and just planning is important, 3D space is important. So the thing is, there's all these specialized modules in the head that are supposed to help a human being survive. And so with Harry Potter, she knows all this stuff, and then she puts it all together, and when it comes out when it comes out through the language, the nested loops get involved, because everything starts getting interconnected to each other. And so the thing is, like, there's the outside world that changes the network in you, and then there's your internal world, your internal model of yourself that changes the network that's inside you again. And so it happens at a certain rate because of physics, like brain cells can only fire 200 times a second, so there's a speed limit. And if we were to go into computers, now if we have a computer and it would have a network, that network would be like a graph, and I suppose that there would have to be specialized modules depending on like the form it would take of like it could take it on a human form, but it could just like be like HAL 9000 with no body whatsoever. And so in the human, so the thing is that like the white matter, when it goes to the back of the brain and it sends connection to the back of the brain, we have imagination. So and then I suppose like she was able to see all of the Harry Potter places and what Harry Potter looked like, and she used her language module to write down everything she saw in her imagination of Harry Potter and everything he did, and like the complete story and stuff like that. So the thing is, we could have a computer network, a graph network in software inside a computer, and it could function the way imagination works. So like it sends stuff backwards into itself, and it sends into language modules, and it sends into like planning modules, everything that's inside the brain right now, the different everything that's specialized, and it could start creating stuff. So it's like it could have an imagination because it's just feeding back into itself the same way the brain does. And when it feeds back into itself, it makes a value judgment of whether or not it's a story that's plausible. So like when you're a little kid, you hear stories, and then that builds the seed that allows you to generate stories when you're an adult and you're a writer. I'm not a writer, but I come up with my ideas, and so that's what this video is about, trying to figure out something, and so that creates interconnection. So the thing is like, okay, so first the computer would have the modules at the bottom, but then it would have at the top it would have a hierarchical, a recurrent hierarchy that is nested. So I guess like since we would have to know how the imagination works. So the thing is that like if it's scalable, if imagination is scalable, if all the parts that specialize in the brain are just like scalable, that we can like build on top of that, then we could probably make it a lot smarter. So I guess like the reason why a person would be smart to begin with is because the speed of the signals and like the way the proteins rearrange themselves when they get the correct signals, and so that mediates how the brain changes. So however we mediate the changing of the network, whether it's in software or in the human brain, that will determine um, crystallized intelligence. So uh, well, it'll mediate crystallized intelligence and fluid intelligence, because um, it's just difficult, because like the network is there and it has to change, and and the variables that determine how it change determine how intelligent or creative it is. And so like that's just that's what I was thinking. And um, but it's in the computer, we don't have to do it with a sparse coding, or we don't have to do it that way. We can have it ordered more correctly in module, like like software. I don't know, like there's the firmware, then there's some kind of other stuff, and then there are applications. It's like the layers of like it begins with the operating system, and below that is machine code. And well, it would kind of be like that, but like I said before, um, modules. Um, so it was just like try to better represent the world, and then also be a self-reflect, where things go back and forth in your head so that you come up with creative ideas. And it would be layered in a hierarchy. So it's like I call it a nested loop hierarchy, and a recurrent nested loop hierarchy. So the thing is that like that you come up with ideas in your head. It's like, and sometimes you see them. So like that it wouldn't even need if it had an imagination, it wouldn't even need a body. It could just like come up with all these geometric forms, just like it would be pretty much if a person that had a visualization could transfer their ideas into a video game setting, and then it would be that way. So the thing is like um, intelligence is like partially intelligence is like manipulation of stuff. So if we figure out how to make a network that changes and that is changed by some like kind of variables, then it would allow us to create stuff inside virtual reality places that we could that and it would be direct. I mean, like if I myself had visualization, and I thought up like some kind of, I don't know, video game world, and I could just create things in that world. That's what this would be. Is that you would have a intelligence that from the recurrent nested loop hierarchy would be able to create worlds, because it not only is it has a self model of itself, it also has a model of everything that's outside of it. And so, and then it could have imagination, because it's feeding back into itself. It's saying like, okay, I'm going to create this, and then I'm going to go over there and see what that guy made, and then he made something cool, and so I guess like I'll add that to my imagination and stuff like that. It's just like it just integrates with new stuff. That's what I think.